Okay, so here's a matrix equation, okay? We have this matrix here. I'm gonna need a different color. We have this matrix here, which we'll call A. We have a vector here. I don't know if you can see the little brackets. We'll call that X. A vector, let's start off right. A vector is a type of matrix. Peeps might get mad at me saying that. YOLO. A vector is a matrix. It is so this matrix A, it has 2 rows, 1, 2, and 2 columns, 1, 2. So A is a 2 by 2 vector, matrix. X is a vector. It has 2 rows, 1 column. It is a matrix that has 2 rows, 1 column. Vector is a subset of matrices. So X, how many rows? 2 rows by 1 vector. Okay? So a vector is just a type of matrix that either has some number of rows and 1 column, or 1 column and a number of rows. If I was gonna, the transpose of X, basically all you do is flip the rows and columns. That would just be x1, x2. So it's the same thing. So this is a 1 by 2 matrix. And because it's a something with it's 1 row and 2 columns, it's a vector, so it gets this fun little sign. So a vector is a matrix where one of the dimensions is 1. I'd even argue a scalar is just a 1 by 1 vector, a 1 by 1 matrix. We can scale this up or down if we want to get into tensors, but I'll save that for later. Okay, so now that we have this in our heads, this is a matrix times a matrix. This just happens to be a matrix that's a vector. Now, forget about that and just think about vectors now. Now I have another one here. And this is Y, okay? Y, and what even are these? They're just collections of numbers. It's like I have these numbers over here. I have these numbers here. And when you do something to them, you get these numbers over here. You're just keeping track of groups of numbers. That's all it is, just groups of numbers. But they can be used to do interesting stuff. Gotta have both hands in here to get the gestures, right? So what do you do when you matrix multiply? They teach you the formula, and you have to be like, oh, is it this times this, or is it this times this, or but check this out. Actually, I'm just gonna use this. Here's how you think about it. You take this, boom, you turn it sideways. You're gonna multiply this by this, A, x2 by B. Because these are all equal, I can put this out here. So we know we want our answer to be in this form, right? So it's going to have 2 rows, 1 column. So this represents 2 equations because you have 2 numbers. So A times x1, A x1 plus B times x2 plus B x2, right? And now down here, C x1 plus D x2. Okay, cool, we did it. We can put this guy back. And so what do I have here? I have 2 equations. I have ax1 plus bx2 equals y1, cx1 plus dx2 equals y2. What is this? This right here, we're gonna go pink. This right here is a system of equations. It's 2 equations. You ever been in math and you need to solve something like this? Bet you have. Let's come up with easy numbers. Let's say A, B, C, D. And again, I could have sat here and written A equals, you know, I could have said A equals 1, B equals da da da, but that would have taken a while, right? So in my head just now, I was like, no, it'd actually be faster. At least it would feel faster. Now write all those equal signs. For me, just go 1, 0, 0, 1. We're going to, you know what? Let's make it a little fun. We'll put a 2 there. So A is 1, B is 0, C is 0, D is 2. Do you see how just writing the matrix instead of writing, you know, C equals 0, D equals 2. You see how this was faster? So it's just like, okay, easier to group the numbers, and, you know, as long as this goes to this, this goes to this, as long as we keep track of it somehow, as long as we have our constant rules, right? It's easier. And so what are the x1 and the x2 that give me this equation? Well, it can be anything, right? Because basically I get apply this, right, up here, and I get A x1 equals just x1, because A is 1, equals y1, because B is 0, so that goes to 0. C is 0, so C times anything is going to be 0. So I get dx2 equals 2x2 equals y2. Okay? So I just get two lines here. I get y1 equals x1, y2 equals 2x2. And you know what these lines look like. And so I can like keep track of these if I want to, just by saying, oh, I gave away the secret. Just by saying that this is just, what was it, x1, 2x2, right? So I just have x1, 2x2. Now, if I put in specific values for my y, I can find the x's for them, right? If I put in y1 equals 4, x1 is 4. So I know there'd be a 4 there. If I put in y2 was 2x2, right? You know, and I put a 4 there, I'd know that x2 is 2. So I'd have 4, 2, right? Cool. So you're really just keeping track of numbers. But the way I want you to think about this is you're doing this, you're multiplying each row by this vector. You're doing a dot product of each row as a vector dotted with this vector. Boom, boom.